So it's to find the domain and range for this. This really is just finding out where you are, and I'll try to make this go right here. We moved over 3, okay, to the left, and we went down 1. Okay, so we went over to the left 3, and then we went down 1. So this means that this is x equals -3, and this is y equals -1. So we're looking for all real numbers except these. So we cannot have -3 for the domain as we move left to right, and we cannot have -1 as we go up and down. Okay, so that's got to be A. And likewise with this one, if we go over to the right one and we go up 2, this means that we cannot have +1 and we cannot have +2. So domain is this guy right here. The x cannot be 1, so that's here, and the range cannot be +2, so it's got to be A. Okay, so now, all right, I see a lot of stuff going on. Just factor. That's all you got to do. Make sure you factor. So you notice I put parentheses around the binomials in case I don't think I cannot cross out things over addition like that. So that n and that n cannot cross out, but this can. Those guys can. Together, as a group, let's see what we can take out here. This is a 9. That would be an n minus 7. So that's it. That 4 and that 9 don't do anything. So it looks like it's A. Here, it looks like we got lots of factoring we can do here. We can take out a 7 and an x squared. So we get an x minus 5. Cool. This guy right here, use the x method, and I'm going to get an x minus 5 and an x minus 3. Okay, so now I'm going to ignore these guys and just look at my green here. Take out a 9 here, that's x minus 3. And then this guy, I can take out a 7x squared and get an x plus 10. Okay, so with all that, this cancels, that 7x squared, x minus 3, and it looks like all I have left is a 9 over x plus 10. All right, it's that simple. Don't make it a big deal. Your last quiz was pretty bad. So gotta really make sure we study for this one. All right, now this is division, so I need to swap these guys. There's nothing to factor, so I'll just leave it like that. But remember, only swap the second the second expression here. Okay, don't do anything to the left. Okay, that'd be x plus 4. So it looks like the 2 x's cancel out, but we still got the 10, we still got the x plus 4, and we still got this guy. And so they're all just on the level, and they're just right there. All right, we're going to make this multiplication, but we're going to swap these guys. So we're going to put the 8 on the bottom, but we're going to take a 3n out so that we get an n minus 1. Now look, if you're wondering how to factor this, just look at what they have in common, take it out, and then after you've taken something out, in your mind, go ahead and redistribute it to make sure that you get this. Okay, that's all you got to do. Take the time to do it. If you don't take the time to check your work, it's just sloppy. It's getting lazy. All right. Now let's take out a negative sign here because I want this in the other order here. So n minus 8. Okay, now remember I can switch the order here if it's a negative. If it was addition, I can switch the order and there's no negative. It's just simply a switch. This guy is a 3n, and that would be an n minus 8. Okay, that's good. 3n, n minus 8, n minus 8. That negative sign and this will become 4. So it looks like I have a negative n minus 1 over 4. Now this is pretty close. In fact, that is it. It's just that let's see what happened. Why is it negative n plus 1? And you can see that what they did is they just distributed the negative sign. So that became negative, that became positive, and that's good. Okay? Look out for either one. This I like better because it keeps the binomial. Maybe you need to use it for another part of a problem, which might happen. But that's good. All right, now here we have addition. So this is not multiplication. We need to, okay, these guys do have the same common denominator. So this one is great. I can literally add these two to get 6v plus 5. And then I've got these denominators here that don't have to change at all. I've already added them. So the answer here is D. Okay, they already have a common denominator. Now these don't have a common denominator. So let's see what we got here. We got a 2 and an x and an x plus 6. And I'll double check that. Yes, okay. Now he has a 3, but he does have an x. So what he needs is this guy. This guy needs a 3. And this guy needs a 2 and an x plus 6. Okay, so he has a 2x, x plus 6. He needs a 3 because this guy has a 3. Now he already has an x, that's this x. So he needs a 2, and he needs an x plus 6 over here as well. So if you give this portion, you must give the top portion the same amount, or else you've disrupted the equality. Okay, you've disrupted the number. Okay, there's no equality here because there's no equal sign. Okay, but what we've got here, when we add, is we have 3x minus 3 plus, I'm going to go ahead and multiply those two, 12x plus 6. Okay, now we've got all of this down here so that we've got a 6x, x plus 6. Now you can take a look here. I do see a 6x plus 6 here. That could be it. Let's just double check. Let's see if we get this up here. We got 3x minus 9 plus 12x plus 72. So now we've got, we still have that denominator. I just don't feel like writing it. We've already established that we're pretty sure it's this, so let's just double check. We got a 15x. Minus what? Take a 9. So 9 times 8, 9 times 7, that would be a 63 over 6x. X plus 6. Okay, so now what's going to come out of here? I do see that they have a common denominator because that is not this. So I'm glad I didn't select it because there's no x squared that comes out of here. So this is not the answer. So I'm going to take something out of here. I can see a 3 comes out of there. So a 3, that would be a 5x. 3 goes in there twice, 21 times. Okay. And you'll notice what happened then is by continually factoring, that guy will factor into that right there. And so our answer is actually this guy. It's A, because we took the time to not go for the low-hanging fruit here, and we took the time to figure out what that is, and now this is accurate. Okay, notice that they actually had 5x plus 22 as well. So if you took out a 3 and didn't do that right, then you might have fallen for that. So be careful. Okay, we'll stop there, and then we'll do the last page. No, we'll do these just because this is, yeah, we'll just do it. Go up to 10 minutes here. These guys have a common denominator, so I can literally just go b plus 6 minus 2b. So we could do this if you prefer. Okay, and then we've got a 9b minus 1. Okay, I just factored out the 9 for no reason. Let's just see if it helps us. Let's see, we got a negative b plus 6 over 9b minus 1. So it looks like this is it right here. It looks like they did not factor out the 9. Whatever, it doesn't matter. Sometimes, you want to be comfortable in both situations, but that is the answer there. All right, now this guy, he has an m plus 6. He has an m minus 3. We cannot combine the two unless we give them what they need. Okay, now when I do that, if I give this guy the m plus 6 and give this guy the m minus 3, what I have is 3m minus 3 minus 4 times m plus 6. Okay, so all of your algebra skills from the previous years are now coming. You have to be good at this stuff. It followed you all along. Okay, so now we're going to distribute 3m minus 9 minus 4m minus 24. Okay, we've got this and this. This is our denominator. So I see it in two situations here. Let's see what this ends up being. I get a negative m minus, let's see, that would be a 30. I can never do the 9s right. 33. Okay. All right. So negative m. Okay, it looks like this guy is it. Nope, no m squared. No, yep, no m squared. No m squared. So, yep, this is the guy. Okay. And notice that this order doesn't matter because of multiplication. Order only matters with subtraction and division. Order is important, okay? But with addition and multiplication, it's called it's too early. Commutativity. All right, there we go. Okay, so looks like we're just stating excluded values. So we are looking for the numbers that will give us 0 in the denominator. Now I'm only going to factor the bottom here because I don't care about the numerator if I'm talking about excluded values. Okay, this would be if you go into computer programming, like excluded value is like, it would be the value that would like make your system crash. Okay, and division by 0 always does that. So you always got to watch out for division by 0. If you get into coding, it usually kind of looks like that, not a real number or something, not a number. So that usually means you're dividing by 0 somewhere. If your debugging software gives you that as an error message. All right, those of you that took CSP might remember that. Let's see, factors of 15, negative 5, and negative 3. So minus 5 and minus 3. It looks like it's 3 and 5. Those are the only values that would produce a bug in my program. So we got to make sure we exclude those. And give the user a message that says, hey, do not enter 5 or 3. But that could be any, like it could be any other number. It could be whatever you need, whatever your program calls for. Okay, it's doing some kind of calculation. All right, what is a common factor out of 28 and 24 other than 2? And I don't see it. It's 2. So that would be, what, 14? Nope, it's more than that. It's 4. 4. And that would be 7m plus 6. So I don't really care about the 4. I want to know what produces 0 right there in the denominator. I don't care about the numerator. We can see here, you remember factoring, it would be negative 6 over 7. It's got to be B.